In this lecture, we're going to talk about the factors that affect bone growth. So we talked about what bone is, we talked about what it's made of, we talked about how it grows. Now let's talk about what are the things that impact how well it grows. And when things go wrong, what are those factors? The first set of factors deals with nutrition. I'm a huge proponent of nutrition being a factor in overall health in general. And it's very important that you're getting the nutrients that you need so your body can function. Your body is literally made out of the food that you eat. So if you're not getting the necessary nutrients, you're not going to be able to build the necessary components of your body, right? So let's go through here, and there's 3 vitamins. Now, a vitamin, it really is just a molecule that your body doesn't make and it needs to survive. Vita means life, right? Vital means life. So vitamin, these are things that your body does not produce that we need to get from food. So you need to eat vitamins. You can't get them otherwise. And the 3 that we're going to focus on are vitamin D, vitamin A, and vitamin C. Now, here's one thing I will make sure that I express to everybody. Our understanding of nutrition is still very, very minimal. It's an area that I think is extremely important. Nutrition science has really started to grow as a field. If I knew how much I was into this earlier on, I might have chosen to go that route because I think it's so important. A lot of the diseases that we deal with in this country are lifestyle diseases, and it has to do with the food that we eat. But let's go through and talk about how these specific vitamins impact bone growth. So the first one is vitamin D. And vitamin D is extremely important, but not because of what you may think. It's important because it allows us to absorb calcium. So calcium is an unbelievably important ion in the human body. We've talked about that a little bit, right? Our bones use it for stability, for structure. It's what makes our bones hard. But also, calcium gets used every time your neurons fire off. Calcium gets used every time your muscles contract. So we use calcium all the time. And here's the problem. Our bodies can't absorb it very well. We don't absorb calcium, our intestines. But what allows us to absorb it is vitamin D. So vitamin D is what allows calcium to be absorbed into the blood. And if there's not enough vitamin D, you're not going to get enough calcium. So you could have all the calcium in the world, and if you're not getting vitamin D along with it, you're not going to be able to absorb it. That's why if you look at milk, it says enriched with vitamin D. They add vitamin D to milk so that way you can absorb the calcium. How do you get vitamin D? Well, you can get it from your diet. Vitamin D is really high in things like eggs, in certain fish like salmon, and in certain vegetables. And also, you'll see here there's a pretty long word, dehydrocholesterol. What dehydrocholesterol is, it's a form of cholesterol that's made in the liver. And what ends up happening is it's not vitamin D, but when UV light from the sun hits it, when it gets close enough to your skin, it actually converts it to vitamin D with UV light. So you may have heard that before, right? You need to get sunlight in order to get vitamin D. You get vitamin D from your diet, and you also get it from sitting out in the sun. So with this, with being inside so much through this virus, I'm guessing our vitamin D numbers are pretty low. So you do want to get outside. So what happens if you don't get enough vitamin D? Well, what that leads to is not enough calcium in your bones, and it leads to what is called soft bones. Bone tissue has 2 components. The hardness comes from calcium, and the flexibility comes from collagen. So when you don't have enough calcium, what you end up with is you get bones that are going to be very soft and rubbery, which is not great for holding up your weight, right? So what that's called is it's called rickets in children, and then in adults it's called osteomalacia. And the difference is at the point with the growth plates fuse over and there's no more growth, at that point it's called osteomalacia. On this next slide, I have an image of that. I'll come back to that. But this is an image of an x-ray of a child with rickets, and you can see the bones are bent. And then what ends up happening is when they eventually calcify, they stay that way. But that is an example of rickets and what it would look like if you have it. Now, the good news is if a child has rickets, they can change their diet, and it should be able to start accumulating calcium and solve that problem. The second type of vitamin is vitamin A. And vitamin A is very misunderstood exactly how it does it. But what we do know is vitamin A is necessary for the development of osteoblasts and osteoclasts. So if you don't have enough vitamin A in your diet, your bones will not develop at the right speed. They'll develop much slower. Your osteoblasts won't be able to function to their optimum ability, and the same with your osteoclasts. So vitamin A, it's just you need it in order to have your osteoblast and osteoclast activity to be at the level it needs to have a functioning, healthy skeletal system. And then the third vitamin is vitamin C. And this is an easy one to remember. Because it impacts collagen, and collagen starts with a C, right? So collagen is the part of the bone matrix that makes it flexible. So calcium makes it hard and strong. Collagen makes it flexible. So when you jump, the force doesn't break your bones. So vitamin C is used for collagen synthesis. So every time your cells make collagen, vitamin C is part of that process. So if you don't have enough vitamin C, that leads to a condition of fragile bones, which means that they're too hard. They don't have the flexibility from collagen, and they break very easily. So if you're somebody who breaks their bones all the time, that could be caused by several things. There's a lot of different issues that can cause that, but one might be you're not getting enough enough vitamin C in your diet. So this is just an image of some examples of foods that are rich in vitamin D, vitamin A, and calcium. So, can you be a vegetarian and still have a healthy diet? The answer to that question is yes. You can actually get vitamins from many different sources. So you can see, like vitamin D, yeah, sure, meat, eggs, and cheese are going to have a lot of vitamin D, but also things like broccoli and squash and sweet potato. So those are all what they call superfoods, right? And then we have our vitamin A. So you're going to see eggs again, dairy, anything with like dairy in it's going to have a lot of vitamin A, but also things like broccoli, again, carrots, fish, and then calcium down here. You can see when you think of calcium, you probably think of milk, but it's not just milk. It's also going to be in things like broccoli and kale and nuts, beans. All those things are high in calcium. This is just that image I showed you earlier of rickets. Okay, now we're going to talk hormones. So hormones impact what a hormone is a chemical messenger that triggers a response. And there's definitely an impact of hormones when we talk about growth. I apologize for the formatting. I don't know why I tried to fix it and it didn't work, so I do apologize. So let's talk about the first hormone, which is pituitary growth hormone, or also known as growth hormone. And it's produced by your pituitary gland. And your pituitary gland actually sits, so this is a brain right here, right? And your pituitary gland sits right at the base of your brain. So it's right there. So if I were to pull this brain in half, your pituitary gland is right down there. And the pituitary gland runs a lot of things. And one of the things it does is it triggers your growth spurt when you hit puberty, right? So when you hit like whatever, 12, 13, 14, however old you were, when you grew a couple inches in 1 year, that was because pituitary growth hormone got released. And what that does is it stimulates the chondrocytes in the proliferative zone of the epiphyseal disc. So we learned all about that. That's what triggers that replication. So if you have not enough, so a lot of times people unfortunately get pituitary tumors. That's a really common tumor that occurs, a tumor on the pituitary gland. And that could lead to two instances. It could lead to too much growth hormone being produced or not enough. So if not enough growth hormone gets produced, it leads to something called dwarfism or pituitary dwarfism, where a person never gets that growth spurt. So they grow up to a certain point, and then when you would normally get a growth spurt, it doesn't happen, and your plates don't ever grow like a normal growth plate. So you end up with what's called dwarfism. If you have too much, that's another problem. You end up with something called pituitary gigantism. And that's when you end up with people that are 7 feet tall, 7'4". Yao Ming is an example, Andre the Giant. And it's a pituitary gigantism as a child. And then once the epiphyseal plates calcify, it is now called acromegaly. It's the same condition. It's acromegaly in adults and pituitary gigantism in children. And then the second type of hormone, which deals with bone growth, is called thyroid hormone. And your thyroid sits right here, and thyroid's involved in several things. We talked about it before, right? We talked about calcitonin, so we know that the thyroid's involved in bone growth. But one thing that it does is it also triggers your bones to calcify when you hit that age where they no longer grow. So if it happens too early, you end up with stunted growth. So let's say, your growth hormone, your thyroid hormone gets released too early to calcify, you might not hit a full growth spurt, and you might not grow to your full height. You might be stunted growth. Okay, this just shows an image of a child. It's a drawing, so it's hard to see, but you can see that the arms and legs are stunted compared to the torso. So this would be pituitary dwarfism. And this woman here, she, I believe, is no longer alive, but she was for a while the tallest woman at 7'8", and she has acromegaly. And one sign of acromegaly is also a chin here, right? So large chin. You can see she's got a very large chin, large feet, and large hands. That's a sign of acromegaly. And you also have you end up being very tall. Unfortunately, with extreme height comes a shortened lifespan. And the reason why is because your heart never grows past a certain size. So as the body continues to grow, your heart just can't keep up. Imagine trying to run like a huge giant tractor trailer truck on a small engine. It just wouldn't work. And let's finish up here. Last couple hormones. The next one is the sex hormones, and estrogen and testosterone are the sex hormones, and they stimulate the ossification of discs and they stop the bone from growing. And estrogen actually has a much stronger impact on bone growth than testosterone. And that's why females hit their growth spurt first. And it's also why women are more prone to osteoporosis. And we're going to talk more about that a little later in this unit. So the sex hormones cause the growth of the long bones, and it also causes them to ossify when you hit age 22, 23. So they're extremely important. And then finally, exercise is the last factor. And physical stress causes bones to grow. And also, unfortunately, if you don't use the bones, they atrophy. So if you use your bones, they build up. And when you don't use them, they atrophy. So, for example, when someone's on bed rest, let's say they have to be off of their, like they get in a car accident and they can't walk for 3 months. Their bones are going to severely weaken because of the lack of stress. The osteoclasts are going to start to really break those bones down. And then when you're working out, though, the opposite is true. You're going to have hypertrophy. Hyper means more. Hypertrophy is when those bones thicken. So I gave you that example before. If you're training for some kind of a team sport, your bones are going to be thicker while you're training because that's triggering osteoblast activity. And when you don't use them, osteoclast activity is triggered and those bones start to break down because your body's trying to conserve resources. You don't want to have extra bone material if you don't need it. And that's everything.